Look out over the ocean on a quiet afternoon, and you see a picture of perfect calm, gentle waves, and sunlight reflecting off the water. Below the surface, this solar radiation is being absorbed directly into the water, loading the ocean with thermal energy. Water is incredibly efficient at holding heat. Across millions of square miles of open sea, the ocean acts as a massive thermal battery, soaking up trillions of joules of energy day after day. What looks like a state of permanent peace is actually a period of deep saturation. The water is holding vast reserves of heat, waiting for the right atmospheric trigger to release it. A slight atmospheric disturbance triggers the process. Warm, moisture-rich air rapidly rises, pulling stored ocean heat up. Hitting the cold upper atmosphere, moisture condenses into towering storm clouds. The Earth's rotation forces these clouds to spin, building a self-feeding mechanical engine. This satellite heat map shows the organized structure of this engine. The vibrant color intensity scale maps the massive kinetic energy wrapping into a distinct circular shape, driving extreme wind speeds across the open water. Through a continuous cycle of evaporation and rotation, a harmless patch of warm ocean air has organized itself into a self-sustaining engine of destruction. Over the next few days, this rotating system drifts across the open ocean. As long as it remains over warm water, it continues to feed, exponentially increasing its kinetic energy and pulling thousands of tons of water vapor into its rotation. But at the very center of this massive rotating system lies a strange paradox. The extreme low pressure in the middle of the storm creates a powerful downward draft. This sinking air clears the clouds away entirely, creating a tranquil, sharply defined open space. Yet immediately surrounding that clear center is the eye wall. This tight ring of towering clouds is where the atmospheric pressure difference is greatest, driving the rotation to its absolute maximum speed and lethal force. The resulting anatomy is a study in physical opposites, a machine built for violent rotation, wrapped around a core of absolute silence. Eventually, this massive kinetic engine runs out of open ocean. The storm makes landfall, and the marine threat translates directly into a terrestrial disaster. The most immediate impact is the storm surge. The immense wind field acts like a plow, physically pushing a wall of ocean water onto the coastline and rapidly inundating communities. Right behind the surge comes the precipitation. Millions of gallons of ocean water, previously pulled up into the atmosphere, are dumped simultaneously, overwhelming natural drainage systems and triggering severe inland floods. At the exact same time, sustained extreme winds relentlessly tear into vulnerable infrastructure and vegetation with raw mechanical force. Landfall is not an attack with intent. It is simply the sudden, violent discharge of the thermal energy the ocean spent months accumulating. However, modern societies do not face this transfer of energy passively. Thanks to advanced meteorological tracking and radar networks, we can observe the storm's formation and accurately predict its trajectory days before it ever strikes the coast, removing the element of surprise. This lead time allows for immediate physical preparation. At the individual level, citizens can harden their homes, securing vulnerable windows and reinforcing structures to withstand the impending kinetic impact. At a societal level, emergency protocols trigger coordinated evacuations. Resources are staged in vast emergency spaces to provide shelter and preserve human life at scale. While we cannot stop a typhoon's physical momentum, these layers of human foresight and communal technology are designed to drastically reduce the human cost of a landfall. The storm's lifespan on land is severely limited. Cut off from the warm ocean water that fueled it, the system starves, rapidly bleeding kinetic energy until it dissipates into a normal rainstorm. While the physical damage left in its wake is severe, the human response is immediate. Communities pivot instantly from survival to organized recovery and rebuilding. Zooming out from the immediate damage, a typhoon serves a vital function. It is a necessary planetary mechanism, acting as a massive heat valve that transfers extreme thermal energy from the equator toward the poles, keeping the global climate balanced. These storms offer a potent lesson. They prove that the planet possesses immense physical power, and our survival depends on understanding that power, respecting it, and perpetually standing ready.